Welcome, ladies and gentlemen. So we're gonna be looking through 5 Python recipes. So we have a basic class. It's a socket connection. What's special about it that it has a dunder enter and a dunder exit method. So here it simply checks for a socket. If it exists, do this. If not, do this, and then exit. If you think about it, wouldn't it be easier for all of us if we could connect to each other's souls just by creating a socket? You connect and bam, that's it. Soulmates for life. Wouldn't it be great? Oh, maybe Satan's working that way, banging sockets day and night in front of the computer. Oh, well, you never know. Sad story. So, the main reason of this class is to open a socket connection and close it. By default, it does nothing. The connection is made on demand with the use of context manager or with keyword. For example, uncomment this. So basically, when we create this class, nothing happens. When we use the context manager, dunder enter is called. And what we do is simply send bytes, we receive bytes, and when everything is done, dunder exit is called. Let me show you. So, this is what we printed out. Next. The main reason behind building a context manager is that you write code that is surrounded by a block of instructions of with context manager. When the with instructions are first given to the interpreter, dunder enter method is being called. In the exit method, dunder exit is being called. The code within block will be executed one way or another, even if there are exceptions. Dunder exit can use the information of an exception or either ignore it, doing nothing and returning none as a result. If dunder exit returns true, the exception vanishes and the program runs as if nothing happened. Currently, we are allowed to have a single socket connection. As seen in code, if more than one connection is done, we raise runtime error. Of course, we can go around and import support for multiple socket connections. So here we simply make a list of connections. In the enter we append the socket, and in the exit we pop it. So, same principle as the first time. Expect this time within a context manager we open another context manager. And here's the first response, here's the second response. So, simple as that. Context managers are used more often in programs that need to control resources like files, network connections, or blocking. The key point of these resources is that they need to be closed or freed in order to work correctly. So depending on your use case, this could be very useful. As you see, we can simply specify these two dunder methods inside of a class and the magic happens. So, part 2. If you have a million of objects that act as simple data structures, you can use dunder slots to significantly decrease the memory usage of your programs. It's pretty straightforward. You define it under slots and give a list of variables. It probably works with tuples as well, and nothing special here. When you use slots, instead of converting each element into a dictionary, Python stores them inside a specific data type with fixed size similar to tuple or a list. Attributes specified inside dunder slots are linked to a specific index of a variable. Only side effect is you can't add new attributes and will be able to use only those specified inside slots. Well, it doesn't matter if you actually don't need them. And if you weren't informed, then Python by default stores all its objects inside of a dictionary, like its functions, its classes, data types, etc. Next, when creating many classes that are used as data structures, it can be eased by defining a temporary buffer from data types that will be the base of your class constructor. And here it is, the magic inside of a class variable. So you define a underscore field inside of the init. We simply check for the length of the fields and the length of provided arguments. We raise a type error if the length isn't what we expected. Otherwise, we zip the values from dunder fields and the values from the arguments provided. So here we create a person, we give it a first name and the last name, and here we simply assign these variables to a person. So that's a basic example. If you decide to give keyword arguments support, then there are a few ways to realize that approach. One way is to reflect keyword arguments so they would correspond to attribute names defined in dunder fields. So let's take an example here. God, I hate when it does that. Okay. Yeah. This one's correct. Okay, so same as before. This time we are doing additional checking. We assign the length of arguments and keyword arguments, and we look if the length is equal or not to the fields provided. I mean, length of the fields provided. So here is the same principle as the last time, and here for each name in self.fields and the length of the arguments, we set the attribute to the name and we pop the name key from the keyword arguments. Next we simply do checking for leftovers, and if there are some, we just print out an error. So let's need to uncomment the socket connection. So some street, which is this here, and we didn't get any errors, so which means this works, and this works, which is what we needed. So moving on, Another way to use keyword arguments as a resource of adding additional attributes that weren't defined in underscore field. So let's take a look at this. Yeah. So here's the same approach. This stays the same as well. And what's new is we have extra args variable where we subtract the keys from the keyword arguments and from the fields. And for each leftover we iterate through it and simply append it. And same way check for duplicates. So this works, I've checked it out, you can play around with it yourself, and I'm not a lazy guy, so I'm gonna actually show you that it's a very legitimate approach and very useful one. So let's take a look. Let's clear it out. So we got an acme, which is this. Let's get a date. We got a date. It's one date. Has no date, but it has a price. So let's get the price. We have the price. Magnificent. Like magic. So, part 4. You need to create a data structure, but you need to limit definition of attributes that can be assigned to a class. Let's say you need to create type checking for specific attributes. In order to do that, you need to customize attribute setup for each attribute. So, here's our descriptor. What it does, accepts the name and keyword arguments. This is very straightforward. It has a $set method. So it takes the instance and it takes the dictionary of the instance and assigns the value to the name. Apologize. This is what I meant that Python stores all its objects as a dictionary. This is why you can use this approach, but it can of course break depending on how your data models are modeled. So next we have a typed class that inherits from a descriptor. It has an expected type and same, it has a $set method. It checks if the value is the same instance of the expected value. If it's not, raise an error, otherwise call its parent class. Like that. So this is the variable limiting. So unsigned, it inherits from descriptor. It has $set. It checks for the value. If it's okay, call its parent. If it's not, raise an exception. Max sized. Almost same principle, expect that it has an initialize defined. So these classes should be looked as basic building blocks from which you create your data model or type system. And we will take a look how they work in action. So here we have an integer. It inherits from typed, and its expected type is int. So basically it does all this, except the type is integer. So unsigned integer, this inherits from integer and unsigned, which is this. This makes sure that the value is higher than 0. String inherits from typed, size string, inherits from string and max sized, which is this. So this is a basic class, and these types can be used to customize it. So they're highlighted just because they're out of the scope. So anyway, this is how they work. You simply create a new class for them and assign all your attributes, and then push them inside of it init. There are a few other ways to make specification limit for a class. One of them is to use decorator class. Okay, so this is pure magic here. We have a function that accepts keyword arguments. That function is another function. It accepts a class. Next, we iterate through the keyword arguments. Then we check for the type, basically. And if the type is correct, the name of the value is equal to the key. And here we set the attribute. Otherwise, the value of this key is value of the key, if that makes sense. So we return the class, we return the decorator. Here we just use black magic and assign the add to it, define everything that's necessary, create a class and assign everything, and that's how it works. Nothing complicated. So next is a meta class. So the base class, which is this, inherits from a type. It has done their new overridden in it, which accepts a class, class name, bases, methods. Methods are keyword arguments basically. They don't have asterisks in front of them. So same principle, loop over the keyword arguments, check for typing, assign the value, return. And this simply inherits it, does everything what the previous examples did. And in the descriptors, base class is a method Sethh, but not get. If the descriptor isn't doing anything but extracting the value with the same name from the dictionary, there is no need to define get. And furthermore, it makes the program slower. So that was it for the fourth part. This is actually very good information. You will definitely be using this if you plan to create some data models for clients, or maybe you will have a job interview where one of your interviewers is going to ask you to look at some code, and if you have something like this in it which you can actually describe what it does, you definitely will get some bonus points. So next, if you need to create a custom class that copies the behavior of a data structure like list or dictionary, but you aren't completely sure what methods you need to define. Let's say you need to create a class that supports iteration. For that, we can inherit from collections.iterable. This example isn't the best. Here we simply try to create a item class, but we get an error that classes containing iter cannot be instantiated. So, of course, if you want to make your class iterable, you can simply override it under iter, which is true. Let's take a look at another example. So, here we have a class, it inherits from sequence. What sequence is, or what it does this. It's pretty understandable for human beings. So that being said, it has an init, it has a dunder items, it sorts the sequence if it isn't none, else it's an empty list. Dunder get item, dunder length, and simply add, which has biscuit bisect in sort. What this does is, if you, for example, have a sorted list and you need to add something in it, bisect will respect the ordering inside of that list and insert the element appropriately. Let's take a look at the documentation. So this is in sort right. Sort right. So insert item X in list A and keep it sorted assuming A is sorted. If X is already in A, insert it to the right of the rightmost X. So basically, if X isn't inside of a list, dump it inside of there, respecting the sorted order. If X is already inside of there, find all the X's, find the rightmost one and assign it right next to it. Basically like that. So let's have some examples. Finally it worked. So here we print the list of items created. Next we print the zeroed element. Then we print the last element. Then we add 2 to it. We print the list. As you see, it respects the order. Then we demonstrate slicing. Then we check if 3 is inside of items. Then we print the length of our list. And next we iterate over each of these elements. So, as you can see, example of sorted item behaves like usual sequence and supports all other operations, including indexing, iteration, length, in checking, and even slicing. Biscuit module used in this recipe gives us a comfortable support for element sorting inside a list. Since biscuit in sort inserts elements inside of a list, the sequence stays sorted. And hope you learned some valuable information. So the code will be up in GitHub. Like, subscribe. You definitely need to like and subscribe. Otherwise, I'm going to find you. So, have a nice day. Hope you enjoyed and see you later.